YAML. Description: the LedoitWolf shrinkage estimator is a particular type of covariance estimator that is more robust to noise and outliers than the standard sample covariance estimator. It works by shrinking the sample covariance matrix towards a scaled identity matrix. This shrinkage is controlled by a parameter, which is estimated from the data using a cross-validation procedure. The resulting estimator is guaranteed to be positive semi-definite, even when the sample covariance matrix is not. This is important because it ensures that the resulting covariance matrix can be used to compute meaningful statistical quantities, such as the Mahalanobis distance. The LedoitWolf estimator is a good choice when dealing with high-dimensional data or when the sample covariance matrix is likely to be noisy. However, it is important to note that it can be computationally expensive to estimate the shrinkage parameter, especially for large datasets. In scikit-learn, the LedoitWolf estimator is implemented in the LedoitWolf function of the covariance module. This function takes as input a data matrix and returns a covariance matrix that has been shrunk towards the identity matrix. The LedoitWolf function has several parameters, including assume centered if true. Data will not be centered before computation. Useful to work with data whose mean is significantly equal to 0 but is not exactly 0. If false, data will be centered before computation. Block size of blocks into which the covariance matrix will be split. This can be used to reduce memory usage and speed up computation for large datasets. By default, the entire covariance matrix is used. Store precision specifies whether the precision matrix inverse of a covariance matrix will be computed and stored. If true, it will be stored in the precision attribute. Tolerance for the stopping criterion of the optimization algorithm used to compute the shrinkage parameter. The LedoitWolf function returns a LedoitWolf object, which has several attributes that can be accessed after the estimator has been fitted to data. These attributes include covariance, the estimated covariance matrix; precision, the estimated precision matrix inverse of the covariance matrix, if store precision is set to true; shrinkage, the estimated shrinkage parameter; location, the estimated location of the data mean of the data, if assume centered is set to false; n samples, number of samples used to compute the estimator. Parameters: name, assume centered; description, if true, data will not be centered before computation. Useful to work with data whose mean is significantly equal to 0 but is not exactly 0. If false, data will be centered before computation. Type Boolean. Default false. Name, block size. Description, size of blocks into which the covariance matrix will be split. This can be used to reduce memory usage and speed up computation for large datasets. By default, the entire covariance matrix is used. Type integer. Default none. Name, store precision. Description specifies whether the precision matrix inverse of the covariance matrix will be computed and stored. If true, it will be stored in the precision attribute. Type Boolean. Default false. Name toll. Description, tolerance for the stopping criterion of the optimization algorithm used to compute the shrinkage parameter. Type float. Default 1 EO4. Name, random state. Description used for random number generation in the shrinkage parameter optimization process. The default value is none, which means that the estimator will use the system's default random number generator. Type integer. Default none. Name, assume finite. Description, if true, data will be checked for finiteness. If false, the data will be assumed to be finite. Type Boolean. Default true. Attributes. Name covariance. Description the estimated covariance matrix. Type array. Name precision. Description the estimated precision matrix inverse of the covariance matrix. If store precision is set to true. Type array. Name shrinkage. Description the estimated shrinkage parameter. Type float. Name location. Description the estimated location of the data mean of the data. If assume centered is set to false. Type array. Name n samples. Description number of samples used to compute the estimator. Type integer. Challenges. Description the LedoitWolf estimator can be computationally expensive to estimate the shrinkage. Parameter. Especially for large datasets. Fixes. Use a smaller block size to reduce memory usage and speed up computation. Use a higher toll to reduce the number of iterations in the optimization algorithm. Use a different covariance estimator, such as the sample covariance estimator, if the computational cost is too high. Description the LedoitWolf estimator can be sensitive to outliers in the data. Fixes. Use a robust covariance estimator, such as the minimum covariance determinant (MCD) estimator, if the data is likely to contain outliers. Pre-process the data to remove outliers before using the LedoitWolf estimator. Description the LedoitWolf estimator can be sensitive to the choice of the shrinkage parameter. Fixes. Use cross-validation to choose the best shrinkage parameter for the given data. Use a different shrinkage estimator, such as the Oracle Approximating Shrinkage (OAS) estimator, if the LedoitWolf estimator is not performing well. Description the LedoitWolf estimator assumes that the data is normally distributed. Fixes. Use a different covariance estimator, such as the robust covariance estimator, if the data is not normally distributed. Transform the data to a normal distribution before using the LedoitWolf estimator.